Hello, my senior scholars. This is Mr. Lowe coming at you once again. This is your video lesson of section 2.3, looking at how to work with a Venn diagram. So we are taking what we know about sets and how to count and things of that nature and applying it to a Venn diagram. So a Venn diagram is nothing more than a visual representation of a set. We use circles to represent the actual sets, and then the elements of the set, or the number of elements for that set, will go inside of the circles. So there are two main types of Venn diagrams. There's a two-circle Venn diagram, and there's a three-circle Venn diagram. So two-circle Venn diagrams is pretty simple. So you have set A and set B. So everything that belongs in set A goes in one circle. Everything that belongs in set B goes in another circle. So notice that there is an overlapping region. So that overlapping region is all of the things that A and B share. All the things that A and B share. So if you remember from sections 2.1 and 2.2, that overlapping region would be known as A intersect B. A intersect B. Anything that they share. Now, if you have a three-circle Venn diagram, it's a little bit more to pay attention to, but still amounts to the same thing. So you have everything that's in circle A, everything that's in circle B, and now we have a third element that's everything in circle C. We have a third set. So that creates some more items. So if they're in A and B, so I'm going to use some highlighter work here. So if they are in A and B, they're in this circle, this oval shape there that I just highlighted in yellow. If they're in both A and B. If they're in both B and C, they're in the highlighted shape that I just put in green. If they are in A and C, then they're in the portion that I just highlighted in blue. So if you've been following along, there is one portion that was highlighted 3 times. So that is where all of the elements live. All the elements that share those 3 qualities. So that's the one I just put in pink. That's the one that was in pink. So if we're using our symbols, obviously A and B together is A intersect B. B and C together is B intersect C. A and C together is A intersect C. So this part here that has all 3 together is A intersect B intersect C. So you write them all 3 together. Write all 3 of them together. So again, 3 sets is a little bit trickier because you got to pay attention to what you're talking about, but it can be done. Definitely can be done. So what we're going to do is we're going to practice creating Venn diagrams, interpreting Venn diagrams, and if you stick it out through a good chunk of the video, we'll end up doing some of the homework problems that you have to give you a sense as to how to solve each problem, how to solve the problems out. So if you stick through it, you'll be rewarded in the end. Let's start with example 1. So U is the counting numbers from 1 to 18, with subsets A being the factors of 12 and B being the factors of 18. So the factors of 12 and the factors of 18. So let's first go ahead and list these out so that we know what we're talking about for each one, and then we'll answer questions A, B, C, and D. So, subset A. So A is the factors of 12, so the numbers that would be in there, 1 times 12, 2 times 6, 3 times 4. So you got 6 numbers inside. That's 6 numbers inside. So B, you have factors of 18, 1 and 18, 2 and 9, 3 and 6. So you've got those numbers. So let's start putting these together. Start putting them together. So A intersect B. So A intersect B. A intersect B, remember, what do they share? Intersect means shared. So they both share the number 1 and the number 2 and the number 3 and the number 6. So 1, 2, 3, and 6. So that's 4 numbers. So that's 4 numbers. So when we're drawing our Venn diagram, there's one circle that will be set A. There's another circle that will be set B. So remember, the overlap goes inside. So that's 1, 2, 3, and 6 going there. So that means the other numbers that didn't get shared go in the other parts of the circle. So for set A, 4 and 12 didn't get shared, so put 4 and 12 in the other part of circle A. For circle B, 9 and 18 didn't get shared, 9 and 18. So there you have it. So we have our Venn diagram. So let's go ahead and answer the rest of the numbers. So A prime. So remember, A prime means the complement. Complement. So we want all the numbers from 1 to 18 that were not in set A. All the numbers from 1 to 18 that are not in set A. So not hard, just tedious because you got to write out the numbers. So you have 1, 2, 3, 4. So 5 is not in set A. 6 is, but 7 isn't. 8 isn't. 9 isn't. No 10. No 11. It does have 12. 13, 14, 15, 16, 17, 18. So there you have it. Complement is list what was in the umbrella set, U umbrella, that were not in set A. What's underneath the umbrella that was not in set A? Letter C, N, A union B. So what this means, the N that's sitting right there means how many elements are in the union of A and B. Are in the union of A and B. So remember, like I told you, order of operations means you start inside the parentheses. So let's start inside of them parentheses. A union B. So we take the A set and the B set, and we unite them. So let's unite them. So they both have the number 1, 2, 3, and 6. We know that already. A brings along 4 and 12. B brings along 9 and 18. So there's your union. So you're asking how many elements are in the union that you just wrote. All you got to do is count them up. 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. So that's all letter C is asking you for. Pretty simple. So lastly, letter D. So you've got A complement union B set. So remember, we already know what union means. Union means take the two sets and put them together. So A prime we technically have already done. So A prime are all those numbers that we listed up there. All the numbers that we listed up there. So I'm going to put C part B. And of course, B is the set of the factors of 18. So 118, 29, 36. So A union B is literally just putting them together. So it's not hard, it's just putting them together. So 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, no 12, 13, 14, 15, 16, 17, and 18. Literally just taking them, putting them together. So there you have it. There you have it. There's your union. So again, those key terms from section 2.2, still need them. Upside down U means shared. The prime means complement. The U written the right way means union. So you have your 3 parts. So you have your 3 parts. So that's problem 1. So that's problem 1. Yes, problem 1 was designed, 1, to illustrate Venn diagrams, but also to illustrate what we did in section 2.2, just in case you need a little bit of a refresher. All right, so let's keep going. Let's keep going. So, problem 2. A group of students were surveyed to determine which of the 3 types of food they liked. Some liked more than one type, and some didn't like any of the 3 types of food. The information is represented in the diagram below. So, this is your 3-circle diagram. 3-circle diagram. So, one of your circles is pizza. One of your circles is hamburgers. And one of your circles is tacos. Now notice that you have a number sitting on the outside. That number sitting on the outside means neither. That means we have 10 people who don't like tacos, don't like pizza, don't like hamburgers. Don't like tacos, don't like pizza, don't like hamburgers. So what we can do is now answer the questions that are associated with this particular Venn diagram. So let's start with how many liked hamburgers. So we're going to start with something simple. How many liked hamburgers? So in this particular case, you're going to look in the hamburger circle. There's the hamburger circle. So I'm highlighting it just to make it more visual. So how many people like hamburgers? You add every number that is inside the hamburger circle. So 3, 2, 1, and 5. 3 plus 2, that's 11 people. So that's 11 people. 3, 2, 1, and 5, 11 people. So, step 2, problem 2, part 2. How many students liked exactly one of the 3 types of food? So exactly one of the 3 types means not in overlap, which means the circle has to be a number that's not in the overlap. So there's 4 overlapping parts. There's 4 overlapping parts. So that's pizza with hamburgers, P and H. It's hamburgers with tacos, and you've got pizza with tacos. So that means you're looking for numbers that are not in overlapping spaces. So that's 4, 2, and 3. So 4 plus 2 plus 3 gives you 9. 9 people. So 9 people there. So let's mosey on to part C. How many students like pizza or tacos? Pizza or tacos. Not pizza and tacos, pizza or tacos. So that means you want the number of people who liked pizza plus the number of people who liked tacos, but you don't want people who liked both. That's what the or means. That's the key thing with the or. You don't want anyone that likes both. You don't want anyone that likes both. So you're going to subtract out the number that liked both. Either you want those who liked pizza or you want those that want tacos. You don't want those that like both. So here's your pizza. So pizza by itself was 4, 3, 5, and 2. 4 plus 3 plus 5 plus 2, 4, 6, 9, 14. Then you need tacos. So we're going to put that in blue. I'm going to circle that in blue. 2, 5, 1, and 3. 2, 5, 1, and 3 is 11. Now you want to take out those that were double counted. In other words, they like both. So here's that part that like both. 2 and 5. 2 and 5. So you add the 2 individually and you subtract the ones that are in both. Because technically, if you're by subtracting them out, you're taking the ones that you're counting twice. You don't want to count anybody twice. You don't want to count anybody twice for the based on the way that they asked this question. So your answer here, 14, 11 minus 7, 18 people. So that's 18 people. And that will actually make a lot more sense in our next unit when we're dealing with probability and statistics. So when we switch to probability and statistics, that's going to make a lot more sense. Last but not least, how many students in total were surveyed? So that's the simplest one in the book here, because we add all the given numbers. That one we just add all the given numbers together. So that's going to work out perfectly for us. So that's 4, 3, 2, 1, 5, 2, 3, and that 10 representing the neither category. So you got to add up all the given numbers. So 4 plus 3 plus 2 plus 1 plus 5 plus 2 plus 3 plus the 10 on the outside. So 4, 7, 9, 10, 15, 17, 20, 30. 30 total people. 30 people. You've got 30 people. So again, 3 circle diagrams are a little bit trickier. Not hard, but they're a little bit trickier to put together and to figure out. So let's do a couple more examples here, and then we'll switch over into a video in which you can use as some homework help for those of you who wish to take advantage of it. Example 3. 120 coffee drinkers were asked whether they use cream or sugar in their coffee. The summary of the survey: 55 use sugar, 36 use cream, 16 use both. So we're talking about sugar and cream, and the fact that they use both. Sugar, cream, use both. Now, obviously, if you add those 3 up, that doesn't add up to 120. So that's telling you that there are some folks that don't like sugar or cream. So we're going to account for that. That don't like sugar and don't like cream. So we're going to account for that. So draw 2 circles. 1 for sugar, 1 for cream, and the overlap is both. So 55 use sugar. 55 use sugar, 36 use cream, 16 use both. So 55 use sugar, 36 use cream, 16 use both. Now, how that is set up, however, is wrong. Now, here's why it's wrong. If you just look at sugar, if you just look at the circle that's sugar, you have 55 and you have 16. Well, guess what? 55 and 16 adds up to 71. 71 people did not say that they use sugar. 55 did. 16 of them just so happened to also use cream. So sugar can only add up to 55. So to figure out what number goes there, to figure out what number goes here, you take 55 minus the 16. So that's 39. So now the sugar adds up to 55 the way it's supposed to. So part B, how many people use sugar only? That's 39. So we go over to the other side. So cream has to add up to 36. That means 16 of those who use cream also use sugar. So the same rule applies. To figure out what that question mark is, 36 minus 16, that's 20. So 20 use cream only. 20 uses cream only. So when you put this all together, how many people use cream or sugar, but not both? So 39 uses sugar, 20 uses cream. So 39 uses, 39 uses sugar, 20 uses cream. That's 59. That's 59 total. because you're not counting those that use both. Remember, you're not counting those who use both. Now, how many people don't use either? Remember, you had a total of 120. You have a total of 120. So that means you have some that use sugar. You have some that use cream. There are people that don't use either. So there's a neither category out here. There's a neither that's sitting out there. So we got to take care of the neither. So let's do that. So since everything has to add up to 120, 39, 16, and 20, 1, 4, 5, 7, that's 75. So 120 minus 75 gives you 45. So your neither is 45 people. Your neither is 45 people. That's it. It's all said and done. Problem's over. Because everything in the end has to add up to 120. So again, knowing how to count and put things in the Venn diagram makes things a little bit more visually representative. Which you're going to be using a lot of visual representation as you transition to college/life in terms of mathematics. So let's do one more, very similar to the one above. In a survey of 20 students, 10 liked pineapple juice, 15 liked orange juice, 7 liked both. 10 liked pineapple juice, 15 liked orange juice, 7 liked both. So, as you can see, 10, 15, and 7 is more than 20. So there's got to be some separation in there. Got to be some separation. So there are some people that like pineapple juice and just pineapple juice. There are some that like orange juice and just orange juice. And there are some that don't like any of them at all. So let's visually represent it. 2 circles. 1 pineapple, 1 orange juice, and there's your both. So remember, the whole pineapple circle, the entire pineapple circle, has to equal 10, no matter what. The entire orange juice circle, no matter what, has to equal 15. So 7 is in the both category. So everything in the pineapple circle has to add up to 10. So that one right there, 10 minus 7 gives you 3. So now it adds up to 10. For the orange juice circle, the overlap and the individual part has to add up to 15. 15 minus 7 gives you 8. 15 minus 7 gives you 8. So there's your Venn diagram. 3 plus 7 plus 8 gives you 18. You need 20. That means there is a neither region. So your neither is 2 people that don't like either one of them. 3 plus 7 plus 8 is 18. Take that away from 20, you get 2. So at least we know what part D is. 2 people don't like either. How many like orange juice but not pineapple juice? So you're looking for the non-overlap. That's 8. Pineapple juice or orange juice. So you want pineapple juice by itself, orange juice by itself. 3 people like pineapple by itself. 8 people like orange juice by itself. That's 11 people. That's 11 people. So, is it difficult? Yeah, it's a little difficult. It's a little bit to put together. But once you put it together, it's something that's very, very easy to navigate because all you are doing is adding and subtracting. There's no multiplying involved. There's no dividing involved. So with that, that completes this video. Now, in the second video that will be uploaded, that video is going to have some homework hints on putting together two circle Venn diagrams and putting together three circle Venn diagrams. So you can use that to help you out with some of your homework if you so desire. That's why it's being put in a separate video. If you don't want to watch it, that's fine. But if you do want to use it, feel free to use it. With that, enjoy your evening. I'll talk to you soon.